Hello everyone, welcome to this session. In this session, I am going to solve the one thermodynamics problem on steam table. The problem is that a rigid vessel of volume 0.86 meter cube contains 1 kg of steam at a pressure of 2 bar. Evaluate specific volume, temperature, dryness fraction, internal energy, enthalpy and entropy of a steam. To find this one, we have to take the properties of the steam at 2 bar pressure. Then by finding those properties we can evaluate the all other parameters such as specific volume, dryness fraction, internal energy, enthalpy and entropy. Okay, to continue with that, first we'll take that is a steam table and the saturated water and steam table pressure based we have to take. And for that from steam table at 2 bar pressure, at 2 bar pressure given in that, for that we have to take in the steam table, here the pressure is varying from 0.622 bar to 2 bar. Okay, in this part of the steam table it is varying this pressure and we have the pressure of the steam at 2 bar, and for that the saturation temperature of the steam is 120 degrees Celsius, and the V up we have taken 0.001061 and V up VG 0.88540 and HF 504.7, HFG 2201.6, and to find the entropy we need to take the SF 1.530 and SFG 5.597, and these whatever the properties of the steam are there, those we have taken. Then moving further, here first we will calculate the specific volume of the steam. The specific volume, by the definition we know that volume per mass of the steam. The volume is given 0.86 and mass of the steam is also given 1. Therefore, specific volume of the given steam is 0.86 meter cube. And from the steam table at 2 bar pressure, the saturated steam specific volume, the saturated steam specific volume Vg we have taken, that is a 0.8854 meter cube per kg. Here one should we note that whenever the pressure specific volume of the steam is there, that will be increases with increase in the, that is change in the wet steam to the saturated steam and saturated to the superheated steam. Then here the saturated steam specific volume is this 0.8854 and specific volume of the given steam is 0.86 meter cube per kg. And as the saturated steam specific volume is higher and the given steam specific volume is lower, then it is a wet steam. Therefore, by comparing these two, we can know that one it is a wet steam. Given steam is a wet steam. So, it is a wet steam and temperature is the saturation temperature that we can take from the steam table at 120.2 degrees Celsius. Okay. Then moving further, to find the dryness fraction, we have to use this equation, this relation, where the specific volume of the steam is given as Vf plus x into Vg minus half Vf. And in this equation, x we have to separate the dryness fraction. Therefore, the dryness fraction x equal to V minus of Vf, the V minus of Vf, and in the denominator Vg minus Vf we have to take. And all the specific volume already we have calculated, and Vf, Vg we have taken from the steam table. Those we can substitute here. 0.86 V minus 0.001061 Vf and Vg 0.88540 and Vf 0.001061. Then by calculating this equation, we are going to get x equal to 0.97172. The dryness fraction of the steam is 0.97172. It is a wet steam. Further moving, the enthalpy of a steam is given by H equal to HF plus X into HFG. Okay, where the HF is the sensible heat and HFG is the latent heat and X is the dryness fraction. Adding these values 504.7 plus a 0.97172 multiplied with a HFG 2201.6. Okay, by calculating this, the enthalpy of the steam we got 2644 kilojoule per kg. Then internal energy is denoted by the U, that is given by H minus PV, because this we have taken from the enthalpy definition. By the definition we can have there is a internal energy plus of the product of pressure and the specific volume. This we know already by the definition of the internal energy as enthalpy, and from that this U we can separate from it. Internal energy U equal to H minus of PV, that parameter we have taken. Then H already we have calculated 2644 minus of pressure is a 202 bar and 200 kilopascal. Therefore, and specific volume is 0.86, and this H is in kilojoule per kg, and this also we can take in terms of the kilopascal. This 200 we have to take in terms of the kilopascal, so that all will becomes in one unit only. Then internal energy we can calculate as a 2472 kilojoule per kg. Then moving further, for the entropy is given by S equal to SF plus X into S sub G, that is equal to 1.53 plus of 0.97172 into 5.597. SF and SF G already we have taken from the steam table, those we have substituted here. By that we can calculate the entropy. The entropy calculated value is that 6.9687 kilojoule per Kelvin. Okay, this whatever the entropy we have taken, like this all the parameters which are required for the calculation in this particular numerical we have calculated. Thanks for watching. If you like, comment and subscribe.